Okay, here we are with our next example. So please go ahead and copy that down and, check your signs, check your exponents. And while you are copying that down, just remember we are going to analyze the changes from the polynomial in original form. Then we're going to plug in a negative x, re-examine the changes. And then what we're going to do is we are going to actually compare our data that we find with the degree of the polynomial. So hopefully you've had a chance to write this down. So let's start examining the sign switches. So this is positive, but that's negative, so that's a switch. This stays, or that's another switch, yeah. It was negative, it switched back to positive, stays positive, switches to negative, and then stays negative. So what we have here is we have 3 changes. So 3 minus 2 is 1, and that's it. 3 or 1 positive real zeros. That's it. We're going to have 3 of them, or we're going to have 1 of them. That's the only combo we can have. Let's see what happens when we plug in negative x. So remember, the only sign that's going to change are our odd exponents. So this is going to change signs, and so is that. So that's going to stay how it is. This is going to stay how it is. That guy's changing. Staying the same. Changing. And of course, a constant is a constant. I can't do much about that. Now remember, I just plugged in negative x here. All right, let's analyze the changes. Starts out positive, and then look, right off the bat it switches signs. So that's 1 change. It stays negative here. There's another flip. It flips back to positive. And then stays positive, and then we have 1 more change there. So for this, we could have 3 or 1 negative real zero. And that's our only combination. So 3 or 1 negative, 3 or 1 positive. Now, let's bring in the degree. And remember, we are focusing on the word real. So I'm going to make a little table just to kind of organize all of our combinations. So remember, we're talking about positive, negative, or the other kind, imaginary. Let's just make a little graphic here to analyze all the possibilities. So if I have 3 positives, now remember the degree is 6, and if I have 3 negatives, then I won't have any imaginary because 3 real, or 3 positive plus 3 imaginary, 3 positive plus 3 negative would equal the degree. Now, what if I had 3 positives and 1 negative? Now 3 plus 1 is 4, but the degree is 6, which means there would be 2 imaginary. So we're just analyzing all the combinations. Now, let's go ahead and change these to 1s. Let's see what happens if we only had 1. So if I had 1 positive, I keep saying real, 1 positive real and 3 imaginary, 3 negative, 3 plus 1 is 4, which means I would have 2 imaginary. Look, all these rows, if you add them up, they all equal 6 going across because that's the degree. All right, I'm going to say these words right this time. Listen, 1 real, I just messed up again, 1 positive, 1 negative. 1 plus 1 is 2. The degree is 6, so I would have 4 imaginaries. So when you look at this combination and you analyze this table right here, if you do not have an even number of imaginaries, then there is a mistake somewhere. Imaginaries always come in pairs. And I'm going to prove that to you, but not today. Just recognize that this whole table was nothing, or it was even numbers right here. All right, so that's called Descartes rule of signs. We have one more to look at, and we'll look at that now.